So here we are making a presentation with regards to biostatistics assignment 3, estimation and hypothesis testing. So it begins, basically this presentation will be an introduction to the concept, and we will begin with this documentation here. Number one, we need to know what the term null hypothesis stands for, the meaning and or application thereof. So the null hypothesis now is what you call a sentence, a statement or claim to be either nullified or rejected or not. It is a statement of equality, so it carries the equal sign. So the null always carries the equal sign. It is a statement that proposes that there is no statistical significance in a given data set. Okay, now the symbol for it is HO. So from now on, when you see HO, you have to say null hypothesis. Second, there's what you call the alternative hypothesis. The alternative hypothesis is a statement. It's also a statement or claim, but it is contrary to the null hypothesis. So it's like two opposing statements. Simply said, it is an alternative to the null hypothesis. It is the hypothesis that the researcher is testing. So the null hypothesis is the one to be nullified or rejected. And the alternative hypothesis is mainly the hypothesis that the researcher is testing. If the null hypothesis is rejected, then the alternative will be the conclusion. If the null hypothesis is not rejected, then the null itself will be the conclusion. And the alternative hypothesis is denoted as H sub A or H1. So if you see HA or H1, you will see alternative hypothesis. Now the following chart depicts a number of different hypothesis tests that exist. So you have two main branches, the parametric test and the non-parametric test. Parametric comes from the word parameter. It's a numerical value calculated from a population. So we can even look up the word parameter. Let's do that. So we look up the word parameter versus statistic. And as it says here, a parameter is a number describing a whole population, while a statistic is a number describing a sample. The goal of quantitative research is to understand characteristics of populations by finding parameters. So once you hear the word parameter, you have to think of a number describing the whole population. So here we have parametric test. This test involves numbers describing the whole population. Numbers like the mean, the median, the mode. We can even look up in Google examples of parameters. So we can look in our notes and we can see, we can do a little revision. Unit 4, numerical analysis of data. Okay, it's chapter 3 in the booklet. The word descriptive measure, it means a numerical value calculated from a data set that can be used to describe that data set, hence the population from which that data set was sampled. Now, the two main categories of descriptive measures are parameters and statistics. Parameters are descriptive measures calculated from a data set obtained by performing a census, use of the entire population. So when you think of, once you hear parameter, you have to think of the population. And examples of parameter is the population mean, represented by mu, the population variance represented by sigma squared, the population standard deviation represented by sigma. So these are examples of parameters. Now, a statistic is a descriptive measure calculated from a data set obtained by taking a random sample. Okay, you are using a fraction of the population. So you have the sample mean represented by x bar, the sample variance s squared, and the sample standard deviation s. Okay, and you have the subcategories. So here now, parametric test deals with the mean, for example, the variance, okay, of the population thereof, okay, and the standard deviation examples. And the non-parametric test now does not involve these descriptive measures. So parametric test involves descriptive measures, okay? Descriptive measures meaning the mean, variance, the standard deviation, very popular descriptive measures, okay? And you can use parametric tests for them. But the non-parametric test does not involve these descriptive measures, does not involve these parameters, okay? And you have them listed here, okay? So these are the two main branches of hypothesis testing. Now, in this course, we're doing a little focus on single sample z-test for mean and chi-square test for independence. And we'll also be doing, here, there's a repetition of single sample z-test for the population mean, that's a parametric test. Single sample t-test, that's another parametric test, because the mean is involved. Independent samples t-test, again, the mean is involved, so that's a parametric test. Paired sample t-test, again, the mean is involved, so that's another parametric test. And one-way ANOVA, analysis of variance, that's another parametric test. Two-way ANOVA, we'll be dealing with that also. That's another parametric test. Parametric tests are very popular, very important. And the chi-square test for independence is not a parametric test because it does not involve a parameter. Okay. So we'll be doing a non-parametric test, the chi-square test for independence. And we'll be doing correlation. Correlation is like a parametric test because it involves the correlation between two variables. And simple linear regression. Comes on the parametric test because it deals with parameters of a population. And for number 11, some definitions of some important terms. Actually, I think these definitions should be first and foremost. I think this should be number 1. Okay. I think we should put this as number 1 because it is more suited for number 1. So this question with regards to definitions will be number 1.